run an aircraft component repair shop at MacArthur Airport. And one of the interesting things about aircraft reliability is everything mechanical on an aircraft has to be pulled on a schedule. Anything like a generator, anything that turns, vibrates, has to be pulled off on a regular schedule, usually 1,000 flight hours. On a jet engine, there's a gearbox on the bottom of the engine. There are 3 accessory pads, one for a starter, one for a generator, and one for a hydraulic pump. This is one of the smallest hydraulic pumps on an aircraft. And the gearbox is turning this drive shaft at 8,000 RPM. Hydraulic oil is coming out, runs the brakes, wing surfaces, other items on the aircraft. When we fix it, we change all the O-rings in it, and then it's certified to go back on the plane with a yellow tag. Something that's very special about these pumps is there's a seal behind the drive shaft to keep the fluid from leaking out of the pump. There's a lot of high pressure fluid inside the pump. Now the seal assembly consists of 2 flat metal plates, and I mean extremely flat, and they're quite expensive. And the way we test that is we'll put the seal under a monochromatic light. This light box puts out a single frequency of orange light. And the way we test the seal is we put a very special glass disc on top of it, very expensive glass disc. It's certified polished to 1 micron, 1/1,000,000th of a meter on both sides. So when we place it on top of this supposedly flat seal disc, we see a very interesting effect of optical interference.
Almost right.
Camera. As I place it on top of the seal, it takes a minute for the air to get out of the way, and you'll see interference lines, and this seal is pretty bad. Where the glass is touching the seal, where the glass touches the seal, you see a bright image, and where the first set of light waves interfere, where the crest of one wave interferes with the trough of the next wave, you'll see a dark line. And these seals were only allowed 4 dark lines across the whole seal. Orange light is 600 nanometers, so we're only allowed 2,400 nanometers of unflatness across the seal. All right, and if it is more than 4 lines, we have to either repolish the seal or throw it out and replace it. So it's a very interesting effect. Let's see if you can.
Is that the line that we see here?
We have to back up a little bit. It's a little blurred. Or if anybody in the front row wants to take a quick look, you can see.
Yeah, I can see him here. Actually, why don't we just do a quick run through?
Everybody.
Yeah.
Everybody.
Everybody.
And we're talking 600 nanometers.
You're only allowed 4 lines.
Right, and we're only allowed 4 lines from one end of the seal to the other. If it's more than 4 lines, the fluid is going to leak out of this high pressure pump.
I think there's a little piece of dust on one side.
That'll do
something with
it.
a glass.
One piece of dust, who knows how many light waves that is.
'Cause that's-
So the
that looks too regular.
second line is where the second set of waves are interfering between the plate and the glass.
So you're allowed 4. How many stripes you got there?
This thing's got about 20,
Yeah.
it's got 20
That's a
stripes.
fail.
Now the bright lines are where the waves are adding up together. And
I missed the beginning, what's the fluid in there?
Well, good question. In the beginning of aviation, it was mineral oil, and which is flammable when it gets hot, or if it leaks on a brake, you get a brake fire. Now it's skydrol, which is an organic ester. If you mix any alcohol with an acid, you get an organic ester, like methyl salicylate from Ben Gay. Methyl alcohol and silicic acid, mix them together, you get methyl salicylate.
So what system is that part of?
Well, this hydraulic pump is on the Embraer 100 aircraft, and these rings are behind this drive shaft. One is stationary and one is spinning against it.
And that's to move control?
Right, and it moves the wing surfaces,
Oh,
landing gears, and the brakes.
All right.
All right, so that's one. There's a lot of science that goes on in an aircraft shop. But that's the first one. Then we have, let's see, something quick on spectroscopy. I've got about a half a dozen spectrum tubes, and this one is filled with chlorine. That's just a thin glass tube. It's got chlorine gas in it under low pressure, and when we excite it with my trusty Tesla coil, get your diffraction gratings out, and you can see the fingerprint of chlorine gas. And what's happening is the chlorine atoms, the electrons in the valence shell, are getting excited to a higher shell, and when they relax to where they belong,
Anybody need one?
when they relax to where they belong, the electrons would give off a photon of a particular
Shut the
color.
screen off.
Right? The diffraction grating just acts like a standard prism. Later, if anybody knows how they get 1,000 scratches per millimeter, talk to me, because I can't fathom it. These diffraction gratings are rated 1,000 lines per millimeter. And that's chlorine. By the way, the charge is going through me and back into the ground because I'm holding it. I've also got, I had a neon spectrum tube, but it broke, but we could just use a neon lamp. And you'd be seeing the characteristic lines of neon. I can draw 8,000 volts to my ring.
Green light?
Tesla coil, they put out a radio frequency energy, early transmission. All right, that's that. That's 2 down.
Question, can you go back to the chlorine tube
Yeah,
thing?
yeah, sure. These spectrum tubes are about $30 each, and you can get them from the vendor on the diffraction grating. The gratings are like 30 cents each.
Yeah, can you turn off the arc light?
Oh yeah, you're getting maybe a sodium lamp image too.
Ah, much better.
And they purposely make the center of the tube very thin so you get the maximum effect through a diffraction grating. They're called spectrum tubes. This isn't something from aviation, it's just something I show to other science kids. Okay, lights. Julian, remember remember me talking about this?
Uh-huh.
Well, I just had to build it.
Move the water, please, in front.
Last week, when I was eating my spicy chicken and broccoli, I was reminded of Robert Oppenheimer and his crew at the Manhattan Project, and how they had to try and figure out how to separate uranium-235 from uranium-238. They're isotopes of one another. The heavier one just has 3 extra neutrons. So what they did is they took uranium oxide ore, reduced it down to uranium, combined it with chlorine to make uranium tetrachloride, ionized it with heat and electrons, shot it through a tube with a magnet at the end of the tube. That's magnetic separation. 2 different size ball bearings. Camera.
Projector then? Right?
We got the whole crew busy now.
So I'll drop the 2 different size steel balls down the tube past the magnet.
Huh.
That will deflect in front of me.
You see the ball is, and a different deflection on the 2 different balls.
The,
Maybe shut the room light.
Yeah.
can you, you're like in the middle of
Oh.
the,
Sort of
Need it for
related
slower.
to separating coins in a machine as well, but
Try
also,
that.
also magnetic separation.
You know, you have to come up and see
Yeah.
because
Yeah.
the camera's not picking up too fast.
No.
you can come up behind the stage too.
You see how the heavier ball wasn't deflected as much? All right, there is some bit of randomness because the smaller ball sometimes wobbles in the larger tube. But if you do it often enough, you'll see. No, that was. All right, you see how the heavier ball is going straight and the lighter ball gets more deflected more.
Yep, definitely love the
Yes.
tape on it too, so you know exactly what happened.
Yeah. I was chasing them all over the kitchen.
It's like a simple mass spectrometer.
Yeah. So that's basically, I had to build this analog of the Manhattan Project. Now, if anybody needs steel balls, let me know. Video time.
Okay, I can, I'm having trouble finding the videos. How do you share? I get the 2 video, I can't find the
I'll
other
do 2.
Okay.
Rich, do we need to change?
Yeah, we gotta switch over.
So,
Oh, no, wrong one.
Which one?
Right, you want the big screen here.
Right, so I wanna get
You want this one.
from that one to here. But, VGA.
This one is pretty much self-explanatory, very short video, some craziness around the house.
Last week I chipped a tooth on some popcorn.
Oh, you gotta make it
So I went
louder.
to the dentist the other day, and the dentist put in a temporary crown on one of my teeth, which is made out of stainless steel, which is mainly iron. And it's right next to a gold crown. So I now have 2 dissimilar metals in my mouth. Two different metals with a liquid in between forms a battery. So let's see. And after I touch my teeth, go down to the meter, which is set to 1 volt. So that's about 1/3 of a volt battery between my two crowns, my steel and gold crown. So in about a week, I'm gonna go back to the dentist. He's gonna take the steel crown out and put in a ceramic crown. So that's your physics for the day. Two dissimilar metals with a liquid form of battery. I could probably get a little higher voltage if I swish around some salt water in my mouth.
Yeah, I don't know where the other, I can't find the other ones I'm looking for. How did you share them? Did you share them with?
You can log into your email and play
I
it.
searched,
It would take too long now, I think I have it on thumb
What's his
drive.
last name?
Matza.
Well, one of the other videos, I was coming back from a vacation recently, and
Yeah, we can't find the other ones, but I can share them with you, so, but you might wanna describe it.
sure, coming back from vacation recently on the plane, and we're at 35,000 feet, cruising altitude. I took my empty water bottle, you know where I'm going with this. And as we repressurized, getting back to sea level, the bottle crushed to about half its size. I shot it in 5 minutes and then shrank it down to 1 minute of viewing, and it's pretty impressive to see how the bottle crushed back to a much smaller size. Something interesting about cabin pressurization on a plane, which my mechanics deal with a lot of the air valves. At 35,000 feet, the outside pressure is 3.5 psi. The pressure inside the plane is 11.5 psi, equivalent to 7,000 feet altitude, which is a little higher than Denver. So the differential pressure between the outside and the inside of the plane is 8 psi.
Rich, go back.
Yeah, it's the other one.
Rich, you had
Go
it.
back, I had the wrong one.
Oh, you can do that one too. Well,
We just go back.
Alright, I gotta
Go back one more.
I found it, what did I do?
We just saw it. So
Yeah, it said bottle up before that.
Alright, let's see.
at the end, I'll mention quickly, at the end of the bottle video, the stewardess came by, kind of yelled
There
at
it
me,
is.
kind of yelled at me a little bit and slapped my tray table up. This is 5 minutes down to 1 minute.
Whoop, we lost the
Pull
signal.
out the cable.
Yeah.
Remember, the bottle is perfectly round at the start. If you look towards the bottom, you'll really see it crush in. Not even close to round anymore.
And this is from when to when?
This is like the last 10 minutes of the flight where you're repressurizing to 14 psi sea level from 11.5 psi, which is altitude pressurization. So as I was saying before, there's an 8 psi differential pressure between the outside and the inside. That's 8 pounds pushing on the inside of every inch of the cabin. Multiplied by 144, that's 1,100 pounds pushing per square foot inside the cabin. So the fuselage has to be quite strong and always round. If you had any other shape, it just wouldn't hold up. Then when you get back to sea level, you know, if the cabin was held at 11.5 psi and you're at sea level, they'd never get the door open. There's the equivalent of about 3 tons holding the door in if they don't repressurize to sea level. There's a computer in the pressurization control, like if it knows you're going to Denver, there's a much higher pressure and they have to compensate if you're landing at Denver a mile up in the air. Okay, last one, the electric starter. As I mentioned before, there's 3 accessory pads on the gearbox of the engine. Here's a starter off an electric starter off of a Learjet, and it calls out to spin up a 3.5-foot slug wheel to 5,000 RPM in 30 seconds or less. That's the test. If it doesn't pass that test, you might get a hot start and damage the turbine blades. So the 3.5-foot slugs translates to about a 90-pound wheel, 16 inches diameter and 4 inches thick. MR squared over 2, Jillian.
Yeah, it's good.
Never thought I would have to use these formulas in college. So when we hit the start button, don't hit play yet. When we hit the start button, there's 2,000 amps coming through these 40 cables. 2,000 amps at 30 volts. That's 60,000 watts going into this electric starter. All right. Also, you'll notice the RPM readout over here, and it just sounds like a jet engine starting up. Go ahead.
Learjet starter test, flywheel, approximately 50-pound flywheel. Okay, 1,500 amps DC input. RPM in about 20 seconds. It passes the test. I'll sign it off. You'll get its yellow tag. It can go back on a plane.
And how much do you charge for that?
To overhaul this starter, about $3,000. That's if it's not burned out. If it's burned out, it's twice the price. It takes a technician about 2 days to rebuild one of these things, and that's a 1,000-hour machine. At 1,000 hours, it's got to come off the plane, get rebuilt. Just something quick. A lot of the things I read: Scientific American, Discover, Physics Today, and my favorite is the Tuesday science section in the New York Times. I also have at least 100 DVDs on PBS Nova, pretty much all STEM topics. If anybody is searching for an old PBS Nova, track me down. If you want to see what happens in an aircraft repair shop, just Google Consolidated Aircraft. You're welcome anytime, one person or a group. And other teachers have been there before, and they just love the tour. That's it.
Thank you, Steve.